Good morning. Today on this Gemini conformity assessment and tooling call, we're really pleased to have Stefan Schlichting give us a tour of a model that he's been developing, a BICEPS Infusion Pump model that is actually a whole lot more. So I hope you enjoy that. So Stefan, take it away.
Thank you very much, Todd, and happy to be on the call. Yes, I would like to give you a short tour through the tooling that we used, Todd and I used to create an infusion pump model, so that we can generate basically descriptions for infusion pumps on the SDC network. So let me give you a short start. So this actually, the model will be a syringe infusion pump, so no LVP, but a syringe, just to make sure. So for those of you that know the BICEPS model, you will find some very similar or familiar concepts that you find also in the standard. Of course, what we did is we created a model in Cameo, SysML model, for the basically the constructs that are defined in BICEPS, and we use this meta model then to instantiate the infusion pump model. So just to give you a very short overview, we of course have MBSE descriptor. We do have a VMD descriptor, a channel descriptor, and in this case an abstract metric descriptor. But of course we do have also all the special, for example, metric descriptors like numeric metric descriptor and so forth. So I basically put in the BICEPS model with all its attributes, or maybe not all, but all that I needed so far, so that I can create a syringe infusion pump. And of course, if you have any questions in between, just please ask them. So what we did over the last, I don't know, 6 months or something like that is we created an instantiation of this BICEPS meta model, which is typed for a syringe infusion pump. And what we used for that purpose is basically the great work from the infusion pump group, where they defined already like an outline, a structure, how such a model could look like for HL7 version 2 or IEEE messages. And we took this work and basically converted it into this BICEPS instantiation. And of course, we had to remodel something just because the methodology or the transport or the domain model is, of course, a little bit different. So here at the beginning, and let me check, I'll give you a favor and highlight it a little bit with colors. Which I typically turn off due to performance. It's easier to read. So we do have an MBSE description here, where basically just the type is currently filled in. We do have a VMD, which is the module for the infusion pump. That's exactly the same as in the IEEE model. And then we do have different channels representing the different measurements or settings of an infusion. And for example, we do have something regarding the loading dose, we do have a clinician dose, a syringe information channel, and a primary infusate source. And we do have something that represents the delivery information, so what is delivered to the patient. And as you can see here, which is not highlighted in the diagram and all the details, they also have different kind of metrics included. They, of course, all have a type, as from the 1173 nomenclature. And if you look into some of the details, for example, in delivery info, there's, for example, something like the current pump fluid flow, which is modeled as a numeric metric descriptor, which I said it's probably some kind of a measurement, and it's probably actually not intermittent but continuous. It has a type and it has a certain unit, so very similar of what you would expect. But it's also the same for the infusion status, and there, of course, it's an enum string metric, and it has these two allowed values modeled. Also has a type, a unit. It should have somewhere the setting, which I obviously didn't set, or which I removed from display. Oh, I can actually directly fix it. Metric category. Oh, no, it's set to calculation. Oh, yeah, because it's not a setting. And it has a volume of delivery total. So these are examples of some of the measurements, and we have them for way more.
Stefan, a quick question with the units.
Sure.
Would you at that point in the model put all possible units, or is it just sample? So for example, you have like for the infusing status, you have dimensionless. If there were other units used there, would that, or possible, would that be listed under the unit equals?
Yeah, so this tool is designed to create one specific description. If, for example, they can change at runtime, you can add in the module here like a group of units, and then it will just have a group of units in there.
Okay, so you could put sets there. Okay.
Yeah, yeah. But for later on for the generation for a tool like for a SDC simulator, you would have to pick one. Because at runtime it can have only one. It can change, of course, but it can have only one specific product.
Okay, thanks.
And then I did model also an alert system on MBS level with a lot of the syringe-related alerts. And I did model only the conditions. I didn't model all the signals so far. And of course, we also created what we need for the patient context, the descriptors, and a clock descriptor. And what we also created is a very simple, just for example or reference, some operations to change, for example, the patient weight that is used as a parameter for calculating or checking drugs or whatever, as well as the height. And we also included like an activate for operation description, for example, to select the program delivery mode as one example, or to apply all the presettings that we might have in there. But that's more exemplary. That's not the full model. Yeah, so this is what we did so far, and what you can do now from within Cameo is you can actually generate an MDIP XML representation out of it, which you could use and load into your preferred Python simulator or use as a starting point for your product. So I just kicked it off, did some debug work in the background, and if I now switch to Visual Studio Code here, there I do see it's probably not readable at all. Why? Possibly it's not installed. Interesting. What? Why is the installer uninstalled? It was just installed a minute ago. So what you, let's see if I can do it manually. View, open, command, format. Format is
always the way when you're doing a demo. It worked a minute ago.
That's the special.
That means it's live, it's real. Otherwise, we wouldn't.
That is true. I don't know. It doesn't really, somehow. It's an XML file, yes. So it should be able to format it. I have no clue. Well, it doesn't. I don't know why. So, but what you can see here, and I'll just do poor man's formatting, is it hammers you the whole XML out that basically represents the MDIP as we just have defined it. So, and this would be now pretty long thing I need to do. I don't know how many characters it has, but it's quite a bunch. So it's about, I don't know, 6,000 characters in there. So it should be the whole document. Yeah, and that's it. That's the starting point for the modeling. So it has the meta model of biceps for the descriptors in it, and it has the you can model. Oh, what I forget is it has, of course, nomenclature included from the 1010X. So it has, yeah, just some nomenclature codes included with, for example, the ref ID, and I sometimes links it to text. And for that, I currently write an importer that it does that correct. It has the CF10 code included. Yeah, that's it. And this is what it uses all to generate the model.
So in short, just to summarize, what you did is you started with a biceps model in here, right?
That's true.
That you then profiled for the infusion pump. You
Yes.
imported the current infusion pump terminology table. And I think I saw some exchanges with Paul Schluter yesterday where you're trying to get some additional event codes and other information. True. But that's what you put in this table here. And then you profiled your biceps SysML for an infusion pump, and you cover not only metrics but also alerting and control. Specifically, you were targeting the kind of control that we're looking at in the Madeira project, right? So you want to be able to support closed loop control. So it's not just everything up to saying go, but I think you, if I remember right, you have a control that actually says, start.
Yeah, that's also something that's in there.
And so it covers all of those functions. But then the other really cool thing here is you did the Python script that actually searches the Cameo database, finds where to start, and then generates the biceps infusion pump specialization. And then you can use the biceps XSD to validate it. So you can actually have a validated XML generated straight out of here. So when we look at this work, Stefan, that was focused on an infusion pump, but it's actually a whole lot more because it gives us a starting point for a biceps SysML representation. It shows us, and then this Python script, which I think is not just infusion pump specific, or it's
no, it would work for any kind of instantiation. You just have to point it to the root of, or to the MDS, and then it generates it. It actually doesn't know anything about infusion pumps. So it's,
and then we also have the and it validates against that. So that's huge, just to say. And I know some of you, I forget who, Martin, David, Bjorn, have also had discussions with Michael Fahn recently, who was saying, wait a second, some of the UML that's in the BICEPS standard published today, it's not really valid UML, or there's some disconnects. You know, there's like 3 ways and it's not clear. So this is actually also addressing that whole issue in terms of making, by the fact that we can validate it against that BICEPS XSD, it gives us that UML representation or SysML representation, which is, again, a huge step forward in my mind.
Yeah, of course, I did some tweaks to the representation that I can easily, for example, include the nomenclature. So that's, for example, I changed some probably things which you could have modeled differently. I changed so that it makes the usage with this external nomenclature easy. But yeah, so that might be something. But of course, it's still a representation of the whole device and or of the whole BICEPS model. And just if it's a filled diamond or if it's an open diamond, that is sometimes, well, could be a point of discussion, and I changed it so that it works nicely in the tool. So it's
yes.
That I don't have to mess around with that.
And yeah, there's some parts, for example, I think there was a few places where you just punted and used a string representation as opposed to going down to the next level and modeling it in finer detail. That's stuff that's like, yeah, well, we can do that later on.
Yeah. For example, it doesn't validate if the period of time, like this one, like the duration is really an XSD duration string. It accepts every string. This will be only found out if you generate the XML file afterwards.
Right.
Which is totally fine, I think. And where you could, of course, have modeled this really like a duration using the right constraints and so forth and SysML, but yeah, I didn't do that part yet.
All right. So I'm sure there's plenty of questions.
Yes, I got one. That's David. First of all, thanks for the presentation, Stefan. Maybe I can just add something. So I think with respect to the diagrams, the UML diagrams from the BICEPS specification, the model you created here is perfectly fitting the idea of coming up with an updated version of BICEPS where we have the updated meta model in there. And I think this is some great work that we can reuse when we are going to do the BICEPS revisions. Second point is I would be interested in doing it the other way around. So is there an option or an import of the XML schema into something that looks like this?
Not yet. Let's put it that way.
Okay.
This is one of the things that's on my to-do list after I talked to Todd, I don't know, a month ago. So it's
okay.
So I guess so. With this specific pilot, right, that we're doing right now, and this is a piece of that around utilizing MBSE, SysML, and a Cameo tool to be able to create a model-centric specification from which we can generate views like documents and graphics and XML specifications. So that's a really good question, as David, as to where the ultimate source of truth lays. And my hope is that we end up actually getting to the SysML representation of the specification as being the single source of truth, as opposed,
yeah. So I think similar to what we have for the RecIF, where we try to establish the RecIF format as the source of truth opposed to the Word document. I think it's similar in that regard, that we don't want to deal with the XML documents, but rather have this formal specification and generate the XML right out of it. So but I think in the first step, plenty of people would like to import their existing XML schemas and then bring them to just a more pretty looking diagram here. And from that point on, starting exporting it.
Yeah, and of course, the funny thing, I don't work with the diagrams normally, so I just work with tables, so because it's way easier. But of course, for generating nice pictures, the diagrams are okay.
Yeah.
But for example, you know, part of the SDPi supplement is volume 3, which has device specializations, which will have an infusion pump, a BICEPS infusion pump. And the content that we'll put in the supplement, right, which is a document, because that's the way that works right now, will be generated or captured out of this model. So at least, and then it'll have pointers into the device specialization infusion pump model. Yeah.
Yeah.
So I would like to hook in a question from John some minutes ago. So when I got your answer right, then your model is just an instance. So it's not a dev spec that you modeled, but it's a normal instance of an infusion pump. So for example, we saw just one unit, and we see that you all marked, nearly all elements are marked with Met A, but I assume that an infusion pump would also be valid having these metrics with Met B or Met C or something like this.
Yes.
So did I get it right that this is an instance and not a dev spec?
Well, in this case, it's a specific instance because I wanted to create the BICEPS XML representation out of it. So
but the tooling is able to get to model a real dev spec, because what we saw today, I was wondering why you made the effort from coming from an XSD, putting it to SysML, only to get an XML back. You should write it directly in XML and validate it.
No, that's to cumbersome, Martin. And you know, I have a preference for generating the XML always.
Yeah, but the question is, honestly, I didn't get the advantage of this SysML.
Oh, it's way easier to handle than the whole XML stuff. If you and you can generate this fancy graphics and so forth. It has a direct link to the nomenclature, so you can't mess up the codes and everything. So that it's just way easier to handle it consistently, I would say, than if you do it in plain XML.
So is the tooling currently more powerful than using XML?
No.
Maybe let's skip the nomenclature part, because this is quite convenient having all things in one tooling. But I think yeah, as you have to pay for Cameo, we would also be able to add this by fancy tooling from Mitel or something like this. So is the UML or the SysML representation more powerful than the XML representation or the XSD representation?
No, of course not. In the end, it's you can have everything in there as well. It doesn't have any additional information. It didn't add any information that is not already in the XML schema.
Okay, and we do not add any possibilities for further checking, for further validation.
No, I didn't do. So you can of course just add validation rules to it. Yeah. So here model validation, but I didn't do that. So.
But isn't getting back to that, isn't one of the advantages of doing it in sort of a tool like this? You're actually getting at an interface that allows you to profile a little bit easier than, you know, doing it strictly through some sort of XML editor, because you're looking at the breakup of the model more logically, and you're seeing the attributes of each object, and then you can constrain those to a particular way that you're interested. In this case, you went right down to the most stringent constraints you can have, because it is an instance. but isn't really the advantage sort of a usability issue of producing various levels of profiles?
Yes, it's. I would say it's easier because I just copy the instances if I want to create a new one and so forth. So that way it's easier. Of course, I could also edit everything in here because here I can read it the same as in the other stuff, but it's, I would say, not so easy and convenient to just edit it.
Yeah, and I mean, even in the future, you can take such modeling and you could essentially build another layer on top of it to make the profiling or the constraints tool a little bit more. You don't have to have Cameo, for example. You could do this other ways, but you kind of need a base set to sort of get started and enable a typical user to constrain information. I mean, that's sort of analogous to a lot of the tooling that Michael's built, that we've built at NIST for B2 and some other projects. So
of course, for example, let's say here's safety classification. This constraint you would have already, so which you can choose. This constraint you would have already also when you have a quite decent XML editor, because they just read the schema, know it's only these 4 fields, and that's it. And with all these other attributes, it's the same. So you can only select what's in the schema, and here you can select what's in the model. That's the same. But,
and then I might also add, remember this is a short-term pilot, right? To see, is this a valid and actually really good way of moving from document-centric to model-centric? But we have the whole tool issue, and I think that's one part that you brought up, Martin. And from what I understand, Piero, I think you especially have mentioned this, is that we will soon see SysML 2.0 out, soon being later this year, soon in standards terms. And that includes an API that should then be able to get us the tool independence we're looking at, as opposed to having to kind of buy into a specific tool set. And that is on the Confluence page for this. I've jotted in the cautionary tale in my mind from HL7, which has used Spark's Enterprise Architect for a long time, for those who are interested in doing that. But it doesn't really follow MBSE SysML. I don't think anybody's really doing that. And it bakes it into the Spark's Enterprise Architect tool. So it's not really a specification that is then interoperable at that level. So hopefully we would be able to end up with a SysML 2.0 version of this, that we could actually achieve that tool independence later this year or early next.
Whenever it is available, let's put it that way.
Yeah.
Yeah.
Well, Piero tells me that it's soon, so.
I have a question.
2 questions were made. Oh yeah, sure, go ahead.
You are fading in and out, Björn. Say something.
So I don't know if there has a question, but this is Steve. I have a question.
Sure.
This is great work, Stefan. Thank you so much. I'm wondering if you could. I'm interested in knowing if this model allows the community to create other MBSE models for other medical devices, like a vital signs monitor. Would you start with this model and replace
I would start
the
with this one.
nomenclature? And I mean, if you could go down the tree, the containment tree on the left, and just tell me, for instance, what you would change, because this is great for obviously an infusion pump. But if you wanted to then make it for a vital signs monitor, for instance, what would you change and how would you go about that, I guess?
Yeah, so I would add a new. Let's assume I have built up the channel or whatever for the infusion for the monitor already. So I would create a new numeric metric descriptor, for example, for a measurement. Let's say SPO2. Of course, I don't have the nomenclature included, so that's. Well,
can you just actually cut and paste the nomenclature or download it from somewhere?
Yeah. Currently, I have the importer is still on my to-do list that it automatically imports it and with all the attributes. So then you can just edit.
Like those are the attributes for the infusion pump, right? But you could delete those or keep those and then import other metrics for the bioscience monitor. I see.
Yeah, whatever it needs to be by me. And so if I now you would basically create it, say okay, define all your attributes, resolution, range, and here we need the type, and let's display both.
So I see you can create them all. But would they be importable from some database?
Yeah, that's what I currently work on with the script, to include them from the RTMMS, just for convenience.
You could actually do that export of a value set for specialization from RTMMS to what, a CSV file or a spreadsheet, and then import that into that table.
Yeah, that's I basically pass the JSON format. Yeah. So let's say, no, I don't have any meaningful unit. I just take any, and that's now, and then we just add it to any channel. It says, okay, do we want to add it as a metric? Yes, we want to do that, and now it would be generated.
Excellent. I just wanted to see, how easy or helpful.
Yeah, once you have imported the nomenclature, the modeling is pretty simple.
Well, this is tremendous. So that's great work. Thanks so much, Stefan.
You're welcome. And so for example, if I now mess this one up, oh no, that would be still correct. Probably this one is not correct. And generate it again. Now actually the pretty printer works again, so which is funny. So and you see here, he said, well, this is not of course, a duration, because now it does the XML schema validation.
Yeah.
And by the way, yeah, here's our metric.
Great.
Stefan, I would also have a question. Piero here.
Hi.
So just to follow up on what Todd said before, I mentioned that SysML version 2 is going to be released sometime soon. Nevertheless, and there is this API feature planned to be released.
Yeah.
Nevertheless, I mean, we don't have to wait for SysML 2 to be able to probably export and import models from different tools. You saw before you made an export in XML. I may decide to import the same XML file just in a different tool, right? It would be a manual work, but that should work theoretically.
Yeah, we can also try to export it in some other formatting or XMI or whatever. We could give it a try if that works.
Yeah, exactly. So and that was just to follow up on what Todd said before. But my question would be, based on your experience and specifically based on this model you created, which in my opinion is very well described and very, very detailed. So congrats on this work. based on your experience, we discussed before the two options, right, of building such a model in XML or working on SysML, right? And you mentioned before that SysML is let's say easier to deal with, right? My question is, and you also mentioned that this model is a specific instance of an infusion pump. Now, if you would consider to abstract this model to make it more generic and perhaps even create another instance, a different instance of an insulin pump, sorry, of an infusion pump, based on your own experience, what would be easier, to do that in SysML or to do that in XML?
Well, I would say it's probably same difficulty, at least for me. So I've worked most of my life with XML, and I've worked a lot of my life with SysML. So it's not that hard in both cases. I think this one is probably, if you look at it from for example, if you have another XML tool like Altova or whatever, they are also pretty powerful from the tooling perspective. And I think that's both okay. I think what's more interesting here is really all the other stuff that you can't do in XML so easy is, let's say, you can associate it, of course, with requirements. So if you have special requirements, you can add them here. You can import the requirements, and let's say you want to say this is somehow applicable to this one. You could maybe say, okay, this is, I don't know, derived, or that's a refine for this object, and you can link all the requirements to it. I think that's something you couldn't easily do in the XML representation. To have all these links to which objects does this requirement belong, and so forth. And that is, for me, the most interesting part, where you can extend it when you combine it with all the requirements, for example, for a device.
And the traceability and being able to link that all the way through. I mean, that's kind of the SysML MBSE part of that. But I think the other thing that you said here, which is really powerful, is the fact that we can take all the work that has been and is being done in RTMMS and leverage that to be able to get a really clear pathway from what is the gold standard now for the device terminology nomenclature, exported into your model. So I think as we go forward, having that as a key point or part of this, in just a very straightforward way of doing that, is huge.
And maybe just for the audience to extend a bit what Stefan showed before, he extended this model by using requirements, going a little bit in what we call the left side of the V cycle, right, in systems engineering. But you may do the same going on the other side, looking at test cases, for instance. Exactly.
Yeah. Be able to get the traceability.
Correct.
That's true. And of course, this one you wouldn't do in the XML schema. So that's.
All right, other questions? Well, thank you very much, Stefan, and
you're welcome.
Really appreciate it. And I am going to wrap up this part and then give you a quick demonstration